Hello everyone, this is GYANADIPTA Mohanty, 19 BC 1224, and this is my digital assignment for Operating Systems course. The topic which I have chosen is Remote Procedural Call. Let's first see what is Remote Procedural Call and why we use it. RPC is a protocol that one program can use to request a service from a program located in another computer on a network without having to understand the network's details. So basically, here we are dealing with an environment in which the processes are executed on separate systems. So we must use a message-based communication scheme to provide such remote service. In contrast to the regular IPC facility, the message exchanged in RPC communication are well structured and are not just packets of data. This is needed because we are actually transporting messages from one system to another system. So a definite structure is a necessity. Now each message is addressed to an RPC daemon, which is always listening to the port on the remote system, and each of it contains an identifier of the function to execute and to pass parameters to that function. The requested function is then executed and any output is sent back to the requester in a separate message. Now we'll see how an RPC works. So RPC architecture has mainly 5 components: client, client stub, RPC runtime, RPC stub, and server. A server stub and a server. Now we'll look at the steps to run. So in the first step, we can see that the client stub, and in one instance of RPC runtime execute on the client machine. The client starts a client stub process by passing parameters in the usual way. It also asks local RPC runtime to send back to the server stub. Now, in the third step, the RPC accessed by the user by making a regular local procedural call. The RPC manages the transmission of messages between the network across client and server. It also performs the jobs of transmission, acknowledgement, routing, and encryption. So basically, if my client has a message to send or a service which he wants from a server machine, so it has to first uh, call that service or send a message to call that service. So my first step would be calling. Second step will be packing my message so that I can send it to the server. And this is done by the client stub, the packing and unpacking. And then when we reach the RPC runtime, my stub request is to send it to the server machine. So now in the fourth step, after completing the server procedure, it returns to the server stub, which packs or marshals the return values into a message. The server stub then sends the message back to the transport layer. So my client machine's RPC runtime was requested to send this to the server machine. So here you can see the call packet is given to the receive side or the receive instance of the RPC runtime in the server machine. Then the server stub unpacks or unmarshals the message. Then it reads the message, executes the service, and then if there is any output or any return values, what it has to do, it will pack the output or the return values in another message, put it into the send instance of the server machine, and then ask it to send to the client back. In the fifth step, the transport layer sends back the result message to the client transport layer, which returns back to the message client stub. Here we can see my client has received the message back. It will now unpack or unmarshal, and then it will read the return values. So in the sixth step, the client stub demarshals, unpacks the return parameters in the resulting packet and the execution process returns to the caller. This is how I will request for a service from a server machine, and then the server machine will return back the return values or the output of the service to the client machine back using RPC. Now we'll go through some issues when we run the RPC. So the first issue that we come across is difference in data representation on the client and server machines. So representation of 32-bit integers. Some systems known as big indent use high memory address to store the most significant byte, while other systems known as little indent store the least significant byte at the high memory address. Now, when my RPC works, how will it know which one to use, a big indent or a small indent? And while sending this information that it is big indent or small indent, this also require a lot of resources to us. So, how do we resolve this problem? RPC systems define a machine independent representation of data. One such representation is known as external data representation, XDR. On the client side, the parameter marshalling involves converting the machine-dependent data into XDR before they are sent to the server. On the server side, the XDR data are unmarshaled and converted to the machine-dependent representation for the server. This is how we resolve it. We use a XDR1 representation, which is machine independent. The second issue which we come across is RPCs can fail or duplicated or executed more than once as a result of common network errors, while local procedural calls fail only under extreme circumstances. How do we solve it? We have a way. Operating systems must ensure that the messages are acted on exactly one rather than at once. Most local procedural calls have exactly once functionality, but it is more difficult to implement. Now let's go through some advantages. RPC provides abstraction, that is message passing nature of network communication is hidden from the user. That means my user doesn't know in doesn't have any information of the network. It doesn't have any information how a particular service is performed and the message is returned back. It just knows that I have to send a message in a particular way with proper parameters and I'll get my service back. RPC often omits many of the protocol layers to improve performance. Even a small performance improvement is important because a program may invoke RPCs often. RPCs enable uses of application distributed environment, not only in local environment. So now my user is not only confined to one system. It can work in many systems using RPCs, and this is called distributed environment, where many systems are connected through a common network. With RPC, code rewriting, redeveloping effort is minimized. So when there's a case of sharing code, my RPCs make it easier because I have an easier way to share my code now instead of rewriting or redeveloping them. Process-oriented threads and thread-oriented models are supported by RPC. That's it for now. Thank you.